Hey guys, welcome to question FM 349 of the Further Maths 4 to 5 study guide. This question reads, Bronwyn is a landlord. One of her duties is to manage the amount of grass surrounding her properties. A shaded grassed area is shown surrounding a square property in the diagram below, and then we're given a diagram that looks like this one. Obviously yours has the shading in it. We're then told the grass is made up of an outer circle around the square property. The circle has a radius of 28 meters. Question A says, use Pythagoras' theorem to show that the side length in meters correct to one decimal place of the inscribed square is equal to 39.6 meters. So what we're going to do to answer this question is create a right angle triangle. We're going to take this here and this diagonal sort of length there. Now, of course, this is going to create a right angle here since this is a square. So we end up with this right angle triangle. And we know that this side is going to be 28 meters. This side is 28 meters. And this side, our hypotenuse, is the unknown. So the basic equation, of course, we're going to use looks like this. And then slight rearrangement so we can get straight to the answer. Plugging some values in here, we get 28 squared plus 28 squared, which if we calculate that and round it to one decimal place, we should get 39.6 meters for that length there of C. And that's part A. Question B goes on to say, what is the area to the nearest square meter of the shaded grassed area? Well, we know that we're going to be able to find that shaded grassed area by finding, so the area of grass is going to be found by taking the area of the circle and subtracting the area of the square. So the area of our circle, well, we know that the formula for this is pi r squared. We know that the radius for our circle is 28, so we end up with pi times 28 squared. The area of the square, well, that's just going to be, we found that before that one side length was 39.6, so since the formula is s squared, side length squared, this is just going to be 39.6 squared. So now using this formula, we should get that the area of the grass is going to be equal to pi times 28 squared minus 39.6 squared, which when we plug that into a calculator and round to the nearest whole meter, we should get 895 meters squared for that answer there. We're then given a little bit more information. We're told to add some variety to the garden. Bronwyn is going to implement changes to the grassed area as shown in the figure below, and then we're shown a figure that looks like this one, except it's got 14 meters in there. Cool. We're then told the radius of each of the smaller circles is 14 meters, as I've just put in there. Question C says, show that angle alpha in degrees correct to one decimal place is equal to 131.1 degrees. Now, this question is a pretty tricky one actually when you start to break it down. In order to answer this question, we've got to think to ourselves, first of all, I know both of these side lengths here, but in order to figure out what this alpha angle is going to require probably a right angle triangle. If we knew what this length down here was, we could use the cosine rule to figure out this angle, but as it stands, we don't know what this is. However, if we were to break it into a right angle triangle like this, so to draw a little bit of a diagram, if we create a right angle triangle here, so that's just the top sort of part of this, then this angle, instead of being alpha, which is twice as big, this would be alpha over 2. So it's going to be half the size of whatever that angle is. We also know that this length here is the same length as the radius, so our hypotenuse is going to have a length of 14 meters. And we can also figure out this length here by remembering that we know that the whole side length of this square is 39.6, which means half of this length here, would be 39.6 over 2. And if we subtract from this 39.6 over 2, the 14 meters that's here, will be left with the distance between the center of this circle and this edge that runs along here. So effectively this distance here. So if we minus 14 from that, that should drop out an answer of 5.8 meters for this side up here. So we also know that this side is going to be 5.8 meters. Now we can actually use trigonometry to figure out the answer to this question. We've got the hypotenuse here, we've got the adjacent side here, so we know that we're going to be using cos of theta equals adjacent over hypotenuse. Our angle, we're going to be using cos of alpha on 2, that's our angle there. And we know that our adjacent side is 5.8 and that our hypotenuse side is 14 meters long. Now from here you can just solve for alpha and get an answer, so you can just write alpha equals, but I'll show you how to do it by hand. We have alpha over 2 is going to equal arc cos of 5.8 over 14, so getting rid of that cos, and then multiplying both sides by 2, we get alpha equals 2 times arc cos of 5.8 over 14. Whacking that into a calculator should drop out an answer correct to 1 decimal place of 131.1 degrees. Part D says, what is the area in square meters of Bronwyn's new shaded grassed area? Round your answer to the nearest square meter. So, in order to figure out the new grassed area, which of course is going to be sort of in here, it's a very rough drawing, but I'm sure you guys get the idea as you can see the actual shading in your books. What you might notice about the old grassed area versus the new grassed area is that all we need to remove from the old area is 2 segments. So this little segment here of this circle and this little segment here, which just so happen to have the same area, as those circles are the same as one another. So if we can subtract 2 of those areas from the old area, we should have the new area. So to start with the area for our old one, well, we know that that was 895 meters squared from what we were what we figured out earlier on in part B. And then if we figure out the area of the segments, we shall have ourselves an answer. So the formula for a segment, one of them is r squared times pi times theta over 360 minus half sine theta, which is effectively just finding the area of the circle, then finding the area of the sector, and then subtracting the area of the triangle within that sector. That's what this formula is doing. So substituting some values in for the area of this segment, we know the radius of this circle is going to be 14 meters. So we've got 14 squared times pi times 131.1, since that's the angle of this segment that we're looking at here, all over 360 minus half times sine of 131.1, and that's our expression for the area of one segment. So putting this all together, our new area is going to be equal to 895 minus 2 times 14 squared pi times 131.1 all over 360 minus 1 over 2 times sine of 131.1, close that bracket, close this bracket, and close the final bracket. Plugging all of that into a calculator should land you with a final answer of 594 meters squared when rounded to the nearest whole meter. And there you have it. If you guys have any questions about the questions that we've shown you here, please leave them in the comments below. Otherwise, I will see you in the next video.